Hello, and welcome to the Your Turn to Play that's found on page 203. So we are going to focus on just 3 of the theorems that we learned about in our last video. We're going to focus on this one that says that if you have a parallelogram, that implies that opposite sides are going to be congruent. And if you have a parallelogram, that implies that the triangles formed using the diagonal of the parallelogram are congruent. And finally, we're going to focus on the third theorem, which says if you have a parallelogram, then the opposite angles are congruent. So those are the 3 that we're going to focus on in this particular Your Turn to Play. And the first question that they ask us, I'm just going to set this right here so you can still see it. The first question that they ask us is to take this, which is in mathematical language, and to turn it into regular English. Why you would want to do this, I'm not exactly sure. But, well, that's not true. When I did it, I did find that it helped me think about what things meant. So, it says, if a figure is a parallelogram, I'm not going to spell it, then the opposite sides are congruent, the triangles formed with the diagonals are congruent, and the opposite angles are congruent. So there you go. That is it for you in English. This is it for you in the easier to write and I think even easier to understand mathematical lingo. All right, let's take a look at number 2. Number 2 says that we are going to prove one of these, and the one that we are going to start with is this one. We have a parallelogram, and we're going to label it A, B, C, D, and they usually go in this clockwise direction. It doesn't really matter. I'm just trying to be consistent with what Fred does. And then we're going to label some of these angles. And again, I'm going to do it the same way that Fred does, only because that might make it easier for you if you're looking at the book and you're also watching this video. If you're not, then you probably don't care. Okay, so we are given that this is a parallelogram. So ABCD is a parallelogram. And we want to prove that triangle ABC is congruent to triangle CDA. CDA. Okay? All right, so that's what we're after, so let's get to it. Now, when I did this, I was able to do it in just 5 steps. It took Fred 6 steps, which might mean that I have left out a part somewhere along the way, but I don't think so. Okay, so let's try it. So our first is that we have parallelogram ABCD, and that is our given. So that's a nice way to start, don't you think? I'm just going to move this so you can see the whole page. There we go. Okay, then our second step is going to be to say, all right, I know that AD is parallel to CB. So AD is parallel to CB. And I know that DC is parallel to AB. So this right here is parallel to that right there. And the reason that I know that is because of the definition of parallelogram. Remember, our definition of parallelogram is any four-sided figure where opposite sides are parallel. And so, since we know that this is a parallelogram, the first thing that we know just by the definition is that the opposite sides have to be parallel. Now, there are indeed other things that we know about parallelograms, but this is what we're going to start with. Okay, so now I'm going to start making some things congruent because I want to get this side congruent to this side. And I'm going to use my knowledge of parallel lines to do that. So I can say that angle 4 is congruent to angle 3. And I can also say that angle 2 is congruent to angle 1. And I can say both of those things because of the PAI. So we have our diagonal line here and our diagonal line here, and here's our transversal. So 2 and 1 are going to be congruent, and 4 and 3 are going to be congruent because of the PAI. All right, so let's mark that. So let me see, 1 and 2 are congruent, and then 4 and 3 are congruent. So now I have 2 sets of congruent angles, which is sweet. So now I can say that AC is congruent to itself. And I can say that because of that wonderful little theorem that I made up. Any segment is congruent to itself. Love it. Okay, there we go. And because I used that theorem, I was able to save myself some an extra step, which is what Fred had to put in his proof. But now I'm able to say that angle ABC is congruent to angle CDA, and I'm able to say that because of the ASA theorem. Or ASA postulate, rather, because I proved an angle, a side, and an angle. So that is that, and I am done. So we have just proven this particular theorem. Okay, so let's take a look at the next one. So the next one that we're going to do is we are going to prove that the opposite sides of a parallelogram are congruent. So we're looking at this, and we are given, this is A, B, C, and D. We are given that this is parallelogram A, B, C, or D, and we are being asked to prove that we'll say AD is congruent to BC. Now, I could do this in a little bit longer of a theorem and put also that we are going to prove that DC is congruent to AB, but you'll see once we do this that once you get started, it's obvious. You would just have to draw your diagonal a different way. All right, let me show you. So here's statement and reason. So the first thing that we know is that we have parallelogram ABCD, and that is our given. Okay, the second thing that we know is that we can draw that line, right? We can draw AC. Draw AC. And we can do that because 2 points make a line. Now, I didn't really have to do this part, right? I could have just drawn it and that would have been fine. But for the sake of, clarity, in case you're following along, I thought I would do that. Okay, so then we know that triangle ABC is congruent to triangle CDA. And we know this because of the theorem that we just proved in number 2. And so I'm going to say that if you have this, then you have this. That was the theorem that we proved in number 2. And now we are going to use it. Okay, so then I know that line segment AD is congruent to line segment CB, right? Don't I know this? I do, because I know that these two triangles are congruent, so I know that those sides are congruent. The reason I give is the definition of congruent triangles. And now we are done with that one. Oh, this is so fun, isn't it? Okay, so let's look here. So we've just proven this. Excellent, there's just one left. Gee, I wonder what the last question is going to be. Okay, so the last one says A, B, C, and D. We are given that this is a parallelogram, ABCD, and we are being asked to prove that angle B is congruent to angle D. Again, I could also prove that angle A is congruent to angle C just by drawing my diagram differently, but I'm just going to do it this way right now. Okay, so we have statement and reason. Our first statement is that we have a lovely parallelogram, and that is our given. The second thing that we are going to do is we are going to draw AC, because 2 points make a line. Ooh, I'm going to sneeze now. Sorry about that. Okay, and then I'm going to be able to say that triangle ABC is congruent to triangle CDA, and I can say that because of this lovely thing that I already proved, right? And so then the fourth thing I can say is that angle D is congruent to angle B because of the definition of congruent triangles. So there you go. That is numbers 1, 2, 3, and 4, which means we are done with this Your Turn to Play. Congratulations.